Now we looked at creating different terrain shapes, and you now know that through Look Dev Nodes you can create all these great looking shapes and get that exact look that you want. But that's only one half of the battle when you're creating a digital terrain. The second half, as you've already seen in some of the early chapters, is creating a great texture map. Because your terrain is so procedurally generated, when you rely on procedural data to create these texture maps, they will be far superior than what you can create by hand, because of course the computer can see certain details that you may not necessarily visualize. Now, you could go two ways with this. You can either go pure procedural and have everything done via data maps and then apply that on your terrain, or you can use that as a starting base, take that into your favorite paint application, and then modify that further. And of course, the third option is you may use this beautiful texture setup that you create to not create a single texture, but rather a splat map or other forms of masks that you can use in your game engine and other applications. But the common thing, and I personally have used all three of them, there's no right or wrong way. It basically is dependent on what the brief is, what your final output is going to be. For example, if it is a game engine, then of course I will have to use the splat map because a single texture map doesn't make that much sense. And in other cases, obviously, you want more hand painting, especially if there's creative direction, and so on. So anyways, none of these are good or bad, but the common component in all of them is that you have to start with a procedural setup. And even if you feel like you would much rather do it by hand, I recommend having a procedural setup because that will be a great starting point. It'll be a great guiding system as well as you go further. And to demonstrate what the different data maps do, first I'll build a random terrain with a few different features, and then we can try texturing that. So I just have a random range node. I don't like this seed. I'm going to try to get something that has more mountains. Well, that looks okay. So I'll make it taller and give it more definition. And I think it needs a bit more bulk, so I will go positive on the shaper and get that. Let's play with the seed just a bit. I'm one of those people who can't help but keep exploring different seeds. You never know what you might find. Okay, this is good enough, but I think this will require a little less of a bulking up. I don't want to lose some of that ridge line that we have there. Okay, so on this, we just want a quick terrain, but we still want it to be very feature rich, so I will rely on our Look Dev nodes and quickly create something. So I'll first shatter this. Let's bring up the resolution so we can see more details. So that looks cool, and I will add maybe a bit of shear on top of this. And I think a little bit of anastomosis in river mode. And I'll increase the impact area and the influence. It's the only non-default setting they're using. Oh, look at that. That's one badass terrain. That is almost too badass. Let's add a bit of erosion. Good old erosion. Please help and save this terrain by adding a bit of sedimentation. Well, let's have it be random sedimentation. And I'm going to reduce the strength and softness. Something like this. I think I went too far on the influence. So I'll go 35. Oh, let's go even lower, 25. And maybe I'll remove the shear because that's adding a bit of extra chaos that I think we could do without. So we'll have this and anastomosis and erosion on top. Or let's just swap it out. I don't want to spend too much time on this terrain. Our focus is going to be the data maps. So there we go. Just, yeah, this looks much better because ideally you don't want erosion going over anastomosis because then it'll take away all the nice little channeling and other details that it's created. Last thing I'll do is increase the impact area now that our influence is lower. There we go, just that extra bit of stuff going on. Okay, so that's our terrain, and we want to now look at all the different kinds of data that we can get beyond just the ones produced by the shaping nodes. So for example, what we have from anastomosis or erosion. We'll try not to rely on those, even though those are data maps and they should be used whenever they can. But our focus is going to be with these nodes, the data map nodes that you find down here. So we've used mask before. Mask is not procedural because it's something that just lets you paint a mask, and then you can use that everywhere. We did that to create our lake areas and other things. So we're not going to worry about that one. Let's look at the more simple ones. So the first one is height. Let me make anastomosis our underlay so we can visualize. So there's our height map. Let's see, the min, max. It just basically creates a mask of a specific altitude area. And you can control the softness with fall off. So if I go just 0, there you go, there's that hard one. Now, this looks deceptively simple, but what you're seeing right now, even though this is at the top and we're just at 18 or 21% here, it's because this uses the full scale of the terrain. So why? Well, it's because you can enter things in meters. So if I wanted to go, give me everything from 320 meters, and I hit enter, it'll transform that into the appropriate percentage, and then go all the way to 500 meters, and enter. It'll mask out that specific area. And if I want the fall off to be similar, like let's say I want it to be 50 meters, then that's 2%, so you get a 50 meter fall off. If you don't want to do this and you want to just eyeball it, then I would say turn on normalized, which then uses the range of the terrain as it is. And now you can go 100% for the very top, so like so, and 0 for the very bottom. This is a great way to visually just go, okay, that's the part I want. And so that's the height node. You can use it for blending different color maps, or applying specific effects to a certain area. Similarly, we have the slope map. The slope map does exactly the same thing, except that it does that on the grade of the slope. So right now, I'm saying give me everything from 0 to 45 degrees on this terrain, and with a little bit of a fall off. So I'll take away the fall off. Now, because our terrain shape is craggy, you will see we get little dots because there will be little features that are within that gradient, and so it will get that. If I just wanted like the lowest part, like the flat floor, so to speak, I will go for the lowest, say 10 degrees. So there we get all of this. You can play with the fall off to kind of have a softer edge. One cool way to visualize is I go 0, 0 on both, but 100% on the fall off, and we get this smoothly graded map of the entire slope. It avoids that craggy look, well, for the most part, because some of these things are quite dramatically perpendicular. But you get the smoother areas here, and you can use that as a texturing component. You'll notice this doesn't have the normalized checkbox because slope, unlike height, will always be normalized. Now let's look at the third super simple basic map, which is angle. The angle basically gives you a directional mask. So right now I'm basically saying give me everything that's pointing to 0 degrees. and I will go 0 on the minimum and 100 on the maximum. So that's the gradation we can get for this. I can go lower, for example. So it stops the spread and it goes exactly 0 degrees. There's still a bit of fall off, so I can take the fall off out as well. You can see this becomes very hard. So normally you could do this to get the hard mask of everything that's pointing towards 0 degrees or whatever azimuth you have set here. I can change it here like this, for example. And with the fall off, you can soften it up, just like we did with the slope. You can go 0, 0 on the min and max, but then increase the fall off 100% and you get this smooth map. So if I open up the 2D view and turn off the lighting, you can see how it looks. It brings out everything. It's almost like a light map. And you can actually use it for diffuse lighting in some ways if you wanted to create something custom, say for the cartography renderer node. One of the ways you can use this is I'll create snow. I'm going to use the angle to induce melt. So we have all this snow, and I'll click advanced and click use melt mask, and then I'll increase the melt. And now the melt will happen more wherever the angle map is brighter. And so here you can see this slope, which let's say maybe it's hidden from sunlight. That's experiencing less melt. This is experiencing more melt. And you can reduce the melt slider here to control that. The other thing you can do is you could actually blur the angle map, because of course you don't want it to be that uniform. Like so. And if I were to put that in, you can see that's a bit more believable. You can also introduce a bit of displacement. Maybe you don't want it to be that uniform. There you go. That's nice and a little dirty, something you would see in nature and not be too uniform. And so that's our angle map. So these are what I like to think of as extremely basic maps, because they don't really do much of processing. They just highlight specific aspects of the terrain as they are. So now let's look at the somewhat more complex maps. One of them is the curvature. So the curvature, it is in many ways similar to the different aspect maps. You could get all the crevices, and wherever the curvature or the slope goes sharply different from what's nearby. And like with the height and slope and angle, you have the min and the max. So you can get the range, and you can have decent fall off between the range, so you can get smoother maps, like so. You can also choose your curvature type. So right now, this is focusing on horizontal curvature. Instead, let's say I wanted to focus on the vertical curvature. You can see it's now starting to highlight these different aspects. And then you can also have the average of both. So with this is a nice texturing component you can use for crevices and maybe adding a bit of accentuation to rocks or other outcrops that exist on your texture map. Let's take a look at occlusion, which is in some ways similar to curvature because it will start highlighting the curves. But instead of looking at it from the geometric point of view of where the sharpest curvature is, this actually looks at how light gets occluded in specific areas. So right now you can see this is, most of it looks white, but if I go to the 2D mode and turn off the 3D surface, you can see these are the parts that get excluded. And this is not like your typical ambient occlusion that you can get through the light node. But what this does, it's more of how natural effects can get occluded in certain areas. So with this, If I were to increase the power a bit, let's increase it further and further still. Maybe we need more passes this time. There you go. This is now much stronger, and I could use this for further effects. So let's say I want more anastomosis. Let's say anastomosis of the destructive type, for example. So I'll go to say destructive here and apply, and I will increase the impact area and influence just because we want the effect to be strong. Go even further. There we go. That's more destroyed than this, but I only want it to happen on specific areas. So I will go here, and because I want it to happen on the lower areas, I will turn off invert. And there you go. It's giving me this area which I can then use as a blending mask. So I'll blend these two and use the occlusion as the blending mask. Oops, I think I inverted the inputs, so I'll reconnect. There you go. And now you can see this is happening on the lower area. So that's a great way where you can use the occlusion. I also like using it for blending two different textures. So sometimes what I'll do is I will create, in fact, I'll illustrate. So let's first create a texture node. And let's give it a sat map. And I'm not going to be too fussy. This is, we'll pick something that is not too complex. So I'll just go for something like this. This is nice. And I'm going to create another one. And let's give it a similar yet slightly different look. So maybe something like this. You can see these are close enough, and I can blend these two by using the occlusion mask. So this is a great way to blend two different texture maps, especially when they're slightly similar and there's that nice slope going on, because that's where occlusion will work best. Next, let's take a look at the flow map. This is so much fun. It's something I rely on a lot. The underlying architecture is the same as what anastomosis uses, but you have far more control over this one. So what you can do now is, as you can see, the settings are very simple. All you choose is the amount of rainfall that should happen, and it'll create a flow map based on that. This is a great way to take existing terrains and create flow maps out of that, which normally you would get out of an erosion node, but sometimes you don't have an option. For example, if you're working with satellite data of a terrain, which I've had to do in many real projects, and you want some of that flow data to create structures within that, new procedural structures, or maybe just texturing, and it's very difficult to do that with just something as simple as slope or height. It doesn't look that realistic. So that's where we rely on nodes like flow. And so here what we have is just a smaller scale flow, which is the tertiary flow. I'm going to untick that and go for a primary flow. And the primary flow will target the bigger structures, things where you have flatter areas like so, or the bigger river networks like this. This terrain doesn't have long-running rivers, but if it had it, this would highlight those as well. If you don't use primary and use secondary, it'll still affect some of the larger networks, but it'll start taking in some of the smaller ones too. And tertiary, we already saw, is working with all the smaller little things, and then similar to that, if we go quaternary, it covers everything. The really good thing is you can actually combine these. So let's see if I went secondary and quaternary, I get both of these. Right now it's uniform blending. So if I untick that, I can actually choose to have secondary be really powerful. Let me lock this so we can see the update. And quaternary can be a more lighter thing going on here. Or if I wanted to increase the effect, then I can do that. You can also choose to have twice the simulation. That will further the flows, and because it's a longer simulation time, it'll confine the flows more to the flow structure and have it go less beyond the flow bounds. Because it's rainfall, it happens everywhere, and so that's why it shows up in some of the not so channely portions as well. But with double the simulation, you can help bring all that flow further into the main channels. And that's a good reminder that the flow node is, like with erosion, a simulation node at its heart. So with this, you can choose the different kind of blending like you saw, and at the same time you can choose the quality as well. Now with flow, generally you don't often need too much quality, so by default we're using just a quarter. But let's say if you were to go half, you get more detail. So the idea is sometimes if you are going to end up blurring this or not really use it for very fine use, like if I'm just using texture blending, then quarter quality is fine. Sometimes you don't want to really worry too much about the tiny details with these flows, so you can use lower quality. But if you want higher quality, then you can of course go all the way up to 1:1, which gives you the most precise simulation possible. It takes a bit longer, but the effect that you get is far more pronounced and detailed. So let's say if I were to go to primary and have 1:1 quality, you can see it's creating more precise flows. So it's really up to you. And lastly, let me just switch back to quarter quality just so we can get a faster output. And you can choose the rainfall. So up until now, we've just used the default, which is 20%. If we go higher, the flows get more pronounced because we have more water coming in. And so if I were to do quaternary, let me take primary as well. And this, let's just go uniform. So there, with a higher rainfall, you get more coverage of the flow structures. You can imagine how great this is for texturing. So if I had, say, just a texture node, and then I can blend that with a flow. Change the grade a little bit. I don't want it to take over everything. You can see now the flows are more accentuated, and then when I give it a sat map, it gets more of that. So if I were to say, let's pick something smoother like this so we can see, I'll lock the preview to here. Let's change the blend. So you can see how this is affecting everything. And like I said, because we're using lower quality, it gets a bit more diffusion, which I think is nicer than having something be too precise. So let's say if I were to use the flow from the erosion instead of this, you see it just becomes too stark like this. Now, of course, you can use both. You can blend the two. But for texturing, I personally prefer to have it be more like this, which shows that this is an aged terrain. Things have happened over a long time. That's why the coloration has shifted through, or rather has flown through the different shapes, and that's why it looks like this. Now, one of the nodes that we have been using constantly everywhere since the first chapter is the texture node. So that's kind of like the foundation for everything we do for creating textures. It uses a mix of many different data types that we have seen already, but it provides it in a ready-made package that you can quickly use to get a general texture for any terrain. You can further modify it, like if you don't want slope to be too big of an influence, you can reduce that. And you can see it's not really worried too much about the slope. Then there's soil, there's chaos, which adds normal randomness. You can control the size of the different patches. You can choose the scale of the overall randomness and other shapes that it's creating. And you can also choose between these three modes. So mode B will start creating different patch shapes. I'll increase the slopes again so we can see. This is a bit too uniform. So there, here you can see it's creating different shape patches in B mode, and then again further in C mode you'll get yet another shape for these patches. So this one's more of like a negatively shaped thing. In the other ones we were focusing more on the outcrops and less on the flows, or in C we will focus more on the flows and these smaller patches like these. And so that gives you more options for your texture. We also have graded. So let me reset this. So there's graded, where basically we get the full graded map of the soil. And if I undo that, we get a slightly, let's say, a darker map, where it's not worrying that much about the soil and the different grades of the soil, but it focuses more on the general structure of the terrain itself. So that's your texture node. There are a lot of different things you can do with it just by playing with it and just randomizing it. And I highly recommend exploring it even when you think a texture looks good. Try a different mode or try different patch sizes and you'll get even better colors sometimes. Now, I mentioned soil. So just like the flow of water, we should also have something for how the soil flows. And that's what the soil map does. This will focus less on the flow like the flow node does, but instead it works on the power of the soils. So if you have a lot of soil, it'll create these graded maps that give you kind of a mask of where the general soil will rest in this map. And you can use that for coloring things, like let's say if it's a desert terrain. In fact, let's create one. We've been relying on shatter and erosion and anastomosis. Let's create something with stacks instead. And if I were to plug that to soil, because it doesn't have that same graded slopes, there you can see it brings out all the places where soil can rest. So it simulates how grains flow with both wind and normal fluvial erosion, gives you all the resting places for these soil deposits. Like with the texture node, which also uses soil inside, you can turn on graded, and it'll give you a stronger map of wherever soil can rest. I'll reduce the power a bit. So there, you can see all the different places, and it's a more graded map as opposed to just the resting places, so to speak. Oh, I just realized I've had the wrong underlay. Let me go here. There we go. Now we can see better. We're using this, not this. So as I mentioned, you can see both the flow structure of the soil as opposed to the flow structure of water. And you can see the different resting places. The big difference between graded or just high-powered is that when you go on a high-powered version, it changes the different shapes. With graded, you can get some of the stronger effects of high power without having to run a longer simulation. And so that's your soil map. You can see if you have a soil map, you can have a flow map. You have all these great components and like the occlusion map. You can use all of that to even drive each other. Like say, for example, I just want the flow maps where the soil occurs. So I will probably just have like an FX map to kind of big this up. And then let me bring it down a bit as well with Shaper. Like so. Attach that to, oops, wrong one. Attach that to the mask of the soil and this. Like so. and now I'm getting the soil flows within that flow area. And then I can of course invert it and go, well, the soil will be the mask for the flows. And while here it may not look like much, when you're doing the actual texturing, that can make a big difference. So for example, let's say I'll give this a sat map. Use something with more contrast than this. Let me increase the bias. There we go. So I'll pin the preview here. So if it didn't have this mask, that's the difference. So lots of little subtle effects, but by masking data with data, you can get more complex things. Now, since we're talking about all these different flows, there's yet one more. It's not always useful, but there are certain instances where you may want the velocity of the rainfall. And that is exactly what the velocity map does. It runs this rainfall simulation to give you the velocity of the water. So as you can see, on stronger slopes and in certain shaped structures, it's brighter. It means the rainwater moves faster here. And then in other places like this flatter area, that's where the water slows down. So you can choose how far the rainfall is. So if I bring it down, it only takes into account this lower area, and the same for the low reach. You can also choose the range of the velocity, like you don't want maybe the higher velocity. And so you can exclude portions that go beyond that velocity. You can also choose which angle. So let me just reset this. And I'll change the angle to say 72 degrees. Now the angle has changed, so the rain is coming from 72 degrees instead of 180 degrees, and then that changes how and where the water flows. This is something you can use for melt in snowfall. You can use it to drive other effects. You can also use it to create flow maps that you can use elsewhere. And so that's why I really like these simulation data maps, such as velocity and soil and flow and occlusion, because they are subtle and can help you create these nice complex texture maps. Now let's take a look at the protrusion map. And I'll go back to anastomosis for this. Which means I'll have to go and pin this as the underlay again. So this in some ways works like the curvature map, but instead of finding the crevices, this focuses more on the protruding things like outcrops and so forth. And you can change the power of this. And it'll focus on the larger outcrops. With a low power setting, it'll focus on all the tiny little protrusions coming out. So this can be a great companion to rock map or texture, any different texturing components that you can use. The other map that we can use for similar simulation as we saw for flow and so on is the growth map. The growth map will simulate places where things can grow, and it by default is a fuzzy map. You can choose to spread it out a bit. You can see the growth is more spread out and not confined to the crevices created by the flow. You can also choose how slope influences the growth. So there it cares less about slope. And you can also force it to follow flows. So if you take fit rivers, it'll confine itself to the more water flow areas. Alternatively, you can choose to have groves. And while it's a slow simulation, it starts creating little patchy groves everywhere. In this, there's a lot of overlap, but you can see there are different groves being created, so it will create clusters of growth. The other thing it can do is, if I reset this and have it promote more wild growth, it starts becoming more chaotic and it starts growing everywhere. It's important to look at the 2D map here. You can see this is very fuzzy, which is something useful for texturing, but you could actually export this as a distribution map for tree instances. So you can take it to some other DCC application and use that to drive scatters. If you want even more precision over the scatter, then you can use the distribution node. Unlike the growth map node, which is more of creating that fuzzy probability of where trees grow, and then you can have a graded solution, this is more geared towards actual instances of trees. So right now this is quite dense. We go here. I'm not sure why it's not giving me the underlay, but oh, because I have the 3D turned off. So there you go. So this is now creating a lot of distribution of trees. I want to reduce the density quite a lot. So there. Now wherever a dot is, that can be an actual tree. So you could export this as a point cloud, for example. We can reduce the occurrence, so now there are fewer trees, and the density, of course, decreases the density of all those clusters. You can try different seeds, and this can be a great way to create trees everywhere. That can be driven with a scatter system. You could even combine this with other data maps to restrict where trees may or may not grow. So for example, this is all good, but let's say I don't want trees growing in the flow structures. So in that case, I would create a flow map like this, and then using a combiner, I would subtract the flow out from the main. So there you can see, maybe I'll increase the occurrence. And there you can see the things won't grow in the flow area. And then if I wanted to further affect that, I can turn on the quaternary flow. That's a mouthful. And there you get this. Again, you could use this as a texturing component as well. So, there are lots of different combinations you can use. The main idea with these data maps is kind of like with the primitives. You get a set of these basic building blocks that you can use in all different kinds of ways. Now let's take a look at something that's literally more superficial. It's the surface texture node. And as the name says, it creates superficial texturing components. So here we're in the sprinkling mode. And it's a little whimsical name, but it does exactly that. It creates different sprinkly little dotted patterns based on wherever different terrain features are. So the more featureful the terrain, you'll get more sprinkling. And you can increase the strength for this and make it a bit more stronger. It's not too visible here, but it's a gray map, so when you see it in color, it'll be more pronounced. The other one is the peaks. So here, like with protrusion, it'll start focusing on the more peaky areas. So this is really cool, where you can take these all these different shapes. It excludes the flow structure in a very, very different way, where it's not using simulation, but it's actually using the shape and certain aspects of the terrain geometry to find these edges and shapes. In the same way, you have sliders. This is a strange little thing which can be fantastic for texturing. Like with other data maps, because our eye can't perceive certain grades of data that well, you might want to use auto level or logarithmic scaling. So if I were to bring up, let's use logarithmic scaling and maybe a bit of shaper. So there we have these. If I increase the strength on this, and so it's all these little sliding areas that you can get. And then finally, not finally, we still have a few more. We have splotches. I will undo our post process so you can see the more simple way it's affecting. So like with the growth or distribution, go to this and sequence there. It's creating this noisy pattern that you can use as a texturing component. And then we also have trace. And so it traces out all the features that exist on this, and that's again another great texturing component. And then you have wind streaks. This is more of a strange arbitrary effect that doesn't have any basis in real processes, but when you look at them on a terrain like this, you get these nice flowy patterns. You could use them as is, you could displace them a bit, like so, to create different shapes. It's just yet another component that you can use for adding randomizations to your texture maps. And the last node for texturing is less for realistic use, but for more for stylized use, and that's the dither node. Let's create a flow map, or let's create rather a slope map. And like we saw before, I'll create a full fall off, so we get this. And if I attach that to the dither node, it creates a dithered pattern. So if I turn off the full 3D effect, you can see it's creating this old school like look that you would get with old compressed image formats like paletted images and so on. The cool thing is you can actually change the pattern. So this is O4x4. There's the Floyd-Steinberg, which is a very well-known dithering formula. It creates that slightly 8-bitty effect. And so there are all these different modes that you can use. This is you can see it's creating a checker pattern. Then there's the 2x2, 3x3, 4x4. These are the size of the matrices. You can also have these halftone effects, like in newspaper printing of old. In that, you can also change the different patterns. And so on and on and on. There are many different patterns, and you also have this cool diagonal line. This can actually look like the way they would do printing blocks a long time ago. So to reduce, like, I just want to introduce a bit of darkness into this. So there you can see. So if, let's say you're creating, like I'll create a cartography output like this, and I can take the output of that, combine it with this, and use multiply. You can see this can be used to add a bit of shading. So if this is your normal cartography output, you can add a bit of shading like so. I think this may be too strong. I'll go back to having the full grade. And there are many different ways to control this. I'm just using this as a flat black output. I would probably end up using a clutter or something to create a different color tone for this. But in any case, if I were to just increase this so we can see it properly, this is a great way to add extra flavor of cartography to your maps. And finally, we have our good old rock map. So we saw that before. Rock map basically takes any protrusion that looks like a rock and creates a dotted shape around it. So, oops, I have it connected to the slope. Let me have it connected to the anastomosis. And I'll turn 3D mode back on. So there we go. Here it's highlighting everything that looks like a rock, giving it that rocky look. Often you don't want to use this by itself. You either blend it with something, often mask it out. But it's a great way to create these little protrusions, especially the really tiny ones. So if you're using like the surface node in LookDev to add little superficial detail, and you want a map to map those out as well, so you can add that to your texture node, then the rock map is a great way to go around doing that. And that's our set of data maps. So with the combination of LookDev and data maps, it should be quite simple for you to get a realistic terrain going in no time. I hope you found this crash course useful. As I mentioned in the beginning, it's really difficult to get on top of all these new things coming out. And while creating digital terrains may not always be something you need, sometimes you'll come up with the need for it. And with this, you'll be able to create something that looks very realistic, very professional, and gives you superb visuals that are flexible. And all of this without wasting too much time. And if you get creative direction to change, because of the procedural nature of this, you can go in and change it. And on that final note of saying that it's procedural, let me remind you that because it's procedural, the possibilities are literally endless. So I highly recommend messing around with graphs, trying different combinations, and you will find that with very little effort, you'll be able to create a dramatic range of visuals. So thank you for joining us, and hope your terrains are always building fast and building beautiful.